Hello students, once again welcome back to my channel. Earlier I have shared quadratic equations part 1, part 2 and part 3 with you all. Many students have requested me to share nature of the roots as well. So here I am back with the PPT. So let us start with nature of the roots. So what do you mean by nature of the roots of quadratic equations? Examining the roots of a quadratic equation implies to find out what types of roots the given equation has. I've already said you how to solve quadratic equation. I've already shown you in the earlier videos. So here we will find out what types of roots the given equation has. Whether it's real, and in real we will have four cases: rational, irrational, equal or unequal. And the next is whether the root is imaginary. I will show you some steps so it becomes more clear to you. So basically, examining the roots of a quadratic equation implies whether the roots are real or imaginary. And if the roots are real, whether it is rational, irrational, equal or unequal, right? Now we have already seen this equation. For the quadratic equation, ax square plus bx plus c equals to 0, where a is not equals to 0, I have already said you why is a not equals to 0. Because if a is 0, this will not remain a quadratic equation, because if a is 0, 0 multiplied with x square will be 0, so it will not remain a quadratic equation. That's why a is not equals to 0. So in this quadratic equation, b square minus 4ac is called discriminant. B square minus 4ac is called discriminant and it is denoted as capital D. This is B, right? And AC, this is A, and this is C. That is, B is the coefficient of X, A is the coefficient of X square, and C is the constant, right? So B square minus 4AC is called discriminant. We will find out the discriminant and then we will examine whether the roots are real or imaginary. So here are some cases. So D is a discriminant here, which is equal to B square minus 4AC. For the given equation, AX square plus BX plus C equals to 0, right? Now the first situation, if the discriminant, that is D, is greater than 0, then we say roots are real and unequal, right? And in this situation, when D is positive, that is greater than 0, if D is a perfect square, that is discriminant is a perfect square, suppose 25, 16, because 5 square is 25, 4 square is 16. If it is a perfect square, roots are rational. We can say roots are rational. If D is not a perfect square, that is, if discriminant is not a perfect square, suppose 17, 19, so roots are irrational. The second situation is if D is equals to 0, that is, if the B square minus 4 is equals to 0, roots are real and equal. And the third situation is if D is negative, that is, it is less than 0, B square minus 4ac is less than 0. Roots are imaginary, that is, they are not real. So we have three situations, and when D is greater than 0, we have two situations. Perfect square, not perfect square, right? So let us move to some sums. 2x square minus 6x plus 3 equals to 0. Now we will compare this equation with the standard equation ax square plus bx plus c equals to 0. So if we compare with this equation, we see instead of a, we can write 2, right? A is 2. And what is the coefficient of x? B equals to minus 6, because ax square plus bx. So b is minus 6 and c is 3. So let us find out now d equals to b square minus 4ac. Right? Now b is minus 6, we do the whole square, minus 4, a is 2, c is 3. So let us substitute the values of b, a, c. So minus 6 is 36. 4 multiplied 2 is 12. 12 times 3 is 30. 4 times 2 is 8. 8 times 3 is 24. So 36 minus 24 is 12. So we can see here the discriminant, that is b square minus 4ac is 12, which is greater than 0. So we can see there are two distinct real roots. Because we know there will be two roots. So these are real roots, distinct real roots. So this is how we determine the roots, whether it is real or imaginary. So here we get d is greater than 0, which is 12 here. So we can write two distinct real roots exist here. Moving to sum 2. Again we compare x square minus 2x plus 5 equals to 0 with the equation ax square plus bx plus c equals to 0. So we get a equals to 1 because a is 1 here, right? Ax square. B is minus 2 and c is 5. So let us substitute the values. B square minus 4ac in the discriminant. D equals to b square minus 4ac. So b is minus 2. Minus 4 into 1 multiplied with 5, right? So minus 2 whole square is 4. 4 minus 20 is minus 16. So here we see that d is less than 0, that is minus 16. Since the negative sign is there, so we can say d is negative, so the roots are imaginary, right? If d is less than 0, roots are imaginary. Now moving to sum 3, 2x squared plus x minus 3 equals to 0. Again we compare this equation with the equation ax squared plus bx plus c equals to 0. So we get a equals to 2, b is 1 here and c is minus 3. Right? So we substitute in d equals to b square minus 4ac, which is the discriminant. So b is 1, right? A is 2 and c is minus 3. So 1 and this minus sign and this minus sign becomes is multiplied and it becomes positive, right? So 4 times 2 is 8, 8 times 2 is 24. And this minus becomes positive. So 1 plus 24 is 25, right? So since d is greater than 0, roots are real, but it is a perfect square as well, right? So the roots are rational because if it is a perfect square, roots will be rational, right? Now sum number 4. Determine the value of k such that the given equation kx squared plus 4x plus 1 equals to 0 has equal roots. Now we know the equation will have equal roots when the discriminant is equals to 0. So let us find out the discriminant. So b square minus 4ac equals to 0 because it is said it will have equal roots. So let us substitute the values. See, a is k here. If we compare with the equation ax square plus bx plus c equals to 0, a is k, b equals to 4 and c equals to 1. So let us substitute the values. B is 4 and a is k here. So we write k, c is 1. So 16 minus 4k equals to 0. So k equals to how much? 4. So this is how we find the value of k. Since it is said equal roots, we write d equals to 0. In this way, you can do other sums. You should remember the 3 cases: greater than 0, less than 0, and equals to 0. And if it is greater than 0, perfect square, what happens? And if it is not a perfect square, what happens? That is what is the situation of roots. Okay. So keep practicing. Thank you for watching my video. If you like my video, do subscribe. And don't forget to press the bell icon. Bye bye. Have a great time.